Hi students, today I am going to explain structure of atom lesson. So for class 9 students, let's see. So in chapter 3 we already learnt what are atoms and molecules. Yes, no, atoms are very small particles, building blocks of matter which cannot exist independently, and matter are composed of all the atoms grouped together. So are called molecules and they can exist independently. So like this we defined in the last chapter. Now we'll learn that atoms and molecules, these are the fundamental building blocks of matter. We already read it. So the existence of different kinds of matter is because of different types of atoms present in them. Now the question arises, what makes the atom of one element different from the other? How the one atom will be different with the other? So are atoms really indivisible? So we cannot divide the atom. Really they are indivisible as told by Dalton. And there are any some smaller particles inside the atom? So all these will be explained in this chapter. So we know that so atom is indivisible told by Dalton, but it is not indivisible. It is divisible. So there are subatomic particles present in the atom. So this is what explained in this. We learn how the subatomic particles and various models which are proposed so that the particles are arranged, the subatomic particles are arranged within the atom. So a major challenge before the scientists at the end of the 19th century was to reveal about the structure of the atom as well as to explain its important properties. So one of the first indication that atoms are not indivisible is after the studying of static electricity. So here they are conducting electricity, means something is there inside the atom, they found out, and they are nothing but charged particles inside the matter. So for understanding the nature of these charged particles, we will do one activity. So just comb the dry hair. So does the comb then attract small pieces of paper? Yes, no, it will attract some small pieces of paper. Or rub a glass rod with silk cloth. So bring the rod near an inflated balloon. What we will observe? So we will observe, so the balloon will be attracted. So from these activities we can conclude that the rubbing the two objects will produce some electricity. So they will be electrically charged. Charge will come when they are rubbed to each other. Then question can be answered by knowing that atom is divisible and it contains charged particles inside. So many scientists contributed in revealing this, the presence of charged particles in an atom. So it was known that in by 1900 that atom was indivisible but contained at least one subatomic particle, that is electron. So first J.J. Thomson told that it contained an electron. So and after that Goldstein in 1886, before that only he told some new radiations are there in a gas discharge tube and he called them as canal rays. So these rays are positively charged radiations which ultimately lead to subatomic particles. Knowing of subatomic particles, these subatomic particles have charge. So the equal in magnitude but opposite in sign. So to that electron. So they have, J.J. Thomson told electrons are there and Goldstein told positively charged radiations are there, and these electrons and these positively charged radiations, they will be in equal magnitude and they but opposite sign, positive and negative sign. So and its mass, when we see that these positively charged radiations have more mass, that is 2000 times more mass than electrons, and at last they gave the name for that positively charged particles, nothing but proton, and electron is represented by E minus and proton is represented by P plus because positive charge, and electron having negative charge E minus. So in the mass of the proton is taken as 1 unit, so plus 1. And mass of the electron is very small because proton's mass is 2000 times more than electron. So its mass we no need to consider negligible. So and we consider its charge only. So it is -1. So it is seemed that atom was composed of protons and electrons. Both protons or electrons are there and they are balancing their charges. So the full atom will be neutral. So mutually balancing their charges, it appears that protons were in the interior of the atom. We can say protons are inside the atom, whereas electrons we can easily remove, but we cannot remove the protons. Now the big question will come. So what sort of structure did the particles of atom have? So now we will see the structure of atom. So in the last chapter we learned Dalton's atomic theory, that atom is indivisible, we cannot destruct it. Yes, no, it is indestructible, means we cannot destroy it like this. But after the discovery of these two fundamental particles, electrons and protons, we can now know that we can divide the atom, so that Dalton's atomic theory is failed. And we can see how electrons or protons are arranged in an atom. Now we'll get the doubt how these electrons or protons are arranged in an atom. For explaining this, first J.J. Thomson came to explain the structure of atom. So according to his theory, J.J. Thomson model of an atom, he proposed a model so that it is like a Christmas pudding. You would have seen the cake of Christmas time. So we will see all the dry fruits will be inside. Yes, no. So the electrons is like the dry fruits which is present inside, and the sphere, that is cake, is nothing but positive charge. So how he told, it is a positive charge, is nothing but cake, and the dry fruits inside is electrons, are nothing but the dry fruit. So electrons are nothing but the dry fruits present inside it. Or we can compare it with a watermelon. So watermelon, watermelon is positive charge, and the seeds which are present inside it are nothing but electrons. Like this he gave the explanation. So Thomson proposed like this: an atom consists of a positive charged sphere. So it contains a positive charged sphere, and electrons are embedded in it. Embedded means electrons are present inside it. And the negative and positive charges will be same, equal in magnitude. Both are equal. How many positive charge is there? That much only negative charge is there. So as a whole it is neutral. So like this Thomson explained the atoms are electrically neutral. So but others like Rutherford explained it. After that he conducted experiments to find out what is actual structure of atom. So Ernst Rutherford was interested in knowing how the electrons are arranged in an atom. So for this he designed one experiment. For this fast moving alpha particles were made to fall on a thin gold foil. He took one gold foil, so which is 1000 atoms thick, and it is very thin layer as possible. And after that alpha particles are nothing but doubly charged helium ions. So its mass is 4 mu. So these are very fast moving alpha particles, and so they have energy also. So it was expected that alpha particles would be deflected by subatomic particles, because atoms are there like this, and when it goes into the atom, so these alpha particles will deflect and come back. He thought like that. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. All went inside and came this side. Very less deflections he can see, and this is called scattering of alpha particles by gold foil experiment. So because of this unexpected result, he didn't expect the result, because he thought all the rays will get deflected, but only little particles get deflected. So most of the moving particles passed straight line through the foil. Some alpha particles were deflected by the foil by some angles, and surprisingly out of every 12,000 particles appeared to rebound. So only some particles rebounded, means it came back in the same path. So in this words, Rutherford, this result was almost as incredible as if you fire a 15-inch shell at a piece of tissue paper, it comes back and hits you. Like this he thought. After that, let us think of an activity in an open field to understand the implications of this experiment. So to find the implication of this experiment, let's think. One child is there. He is in front of a wall with his eyes closed. He throws stones at the wall from a distance. What happens? He will hear the sound whenever he strikes a stone on it. So if he repeats this 10 times, if he should hear the sound 10 times. But because all the 10 stones will hit the wall. But if a blindfolded child was allowed to throw a stone in a barbed wire fence, so fence is there. So when the fence is there, no sound would be heard, because in the fence all the stones will not be hit. On the wall all the stones will be hit, but in the fence some will go inside it. So all the stones will not be hurt because of gaps present in the fence. Same here also, the same reasoning he gave for this experiment also. Most of the space inside the atom is empty only. So inside the atom all the space is empty, because most of the alpha particles pass through the gold foil without getting deflected. So because of empty space, all went inside fast. Then very few particles deflected from their path, because positive charge of the atom occupies very little space. So protons which is present positive charge, they are occupying very little space. When it hits that, then only it is rebound back, it is coming back, so deflected. And a very small fraction were deflected by 180 degrees, so came back by 180 degrees, indicating that all the positive charge and mass of the gold atom were concentrated in a very small volume. Means nucleus is very small, they are only deflected and came back at 180 degrees. Like this he concluded. So from this idea he calculated the radius of the center of the nucleus of the atom. So from this he gave some features, like there is a positively charged center in the atom called nucleus. So there is a positively charged center called nucleus. So nearly all the mass of the atom present in the nucleus only. So the electrons will be revolving around the nucleus in circular paths. So he estimated that proton, which is a positive charge, is present inside the nucleus here, and electrons will be revolving around it, around the circular path, and the size of the nucleus when we compared with the atom is very small. So we can see it, only this pointed structure is nucleus, so size is very small when we compare to the atom. So what are the drawbacks, what he did wrong, we will see. So the revolution of the electron in circular orbit is not expected to be stable. So here the electrons are revolving around the nucleus, and how it will be stable. So any particle in a circular orbit will undergo acceleration. So when it undergoes acceleration, when it is rotating around the nucleus, what happens? It will release some energy, means it will lose the energy, and finally it should be losing all the energy, and it will become unstable and it will collapse. But it is not happening, no? Atom is stable. Then how it is possible? This is not explained by Rutherford model. That's why it is failed in this time. After that, Bohr's model, which gave us a stable atomic structure. So in order to overcome these objections of Rutherford model, Niels Bohr, this man, so put forward the following postulates. What he told: only certain special orbits known as discrete orbits of electrons are allowed inside the atom. So inside the atom, here this is nucleus, proton is there, and the electrons are revolved around the special energy orbitals. So this is called discrete orbitals, and they will not lose energy in these. So the electrons while rotating, they will not lose energy. So that is why they will be stable. So these orbitals or shells are called energy levels. Each orbital will have some energy. That's why they are called energy levels. So as shown in the figure, we can see. So this is the nucleus, and the first shell is called K shell. Second shell is called L shell. Third shell M, N. Like this, so many shells will be there, and they are also called energy levels in an atom. So like this, we represent the shells by the letters K, L, M, N. So like this, Bohr's model gave a stable atomic structure, overcoming the objections of Rutherford. Next, neutrons. Up to now we only discussed about protons and electrons. After that, neutrons came to light by Chadwick. So Johnson Chadwick discovered another subatomic particle, but they don't have charges. So they have no charge, and the mass is equal to the proton. And where it is present? It is in the nucleus. Yes, no, it was eventually named as neutron, and it is also present in the nucleus, except hydrogen. Hydrogen don't have neutron, it have only one proton and electron. as it has atomic number only 1. Yes, no? So a neutron is generally represented by n, and the mass of an atom is therefore given by, so we can, because electrons mass is very negligible, we cannot consider it. We can take the mass of an atom by sum of masses of both protons and neutrons in the nucleus. So like this we can give the mass of the atom by adding the mass of the protons and neutrons. So like this we can do. I will continue the lesson in the next part. Thank you.